Hello everyone, my name is Shams Raza. I'm an Azure cloud specialist with more than 6 years of experience in designing and architecting on-premise cloud and hybrid infrastructure setups. Currently, I'm working with one of the top 5 IT consulting organizations in India, and earlier I had the opportunities to serve as a vendor consultant for Microsoft hybrid cloud solutions. In today's video, we are going to deep dive into continuous integration using Azure Pipelines in Azure DevOps. We will learn that how continuous integration helps automate the builds, improve the code quality, and accelerate the delivery, all while ensuring your applications are reliable and scalable. So let's get started by understanding what continuous integration is, and then we will move into how Azure Pipelines make it simple to set up automated builds and test for your projects. Azure Pipelines. Azure Pipelines is a continuous integration, delivery, and deployment service for CI/CD, allowing for automatic building, testing, and deployment of the code. CI/CD is one of the fundamental tools of DevOps implementation strategy, and implementing Azure Pipelines for continuous integration of code lets the developers find bugs easier and earlier in the development and code testing phase as a part of build process and thus ensuring the code quality. So the steps are that we will be creating a build pipeline in Azure Pipeline using the classic editor. Then in the next step, we will run the build manually against the main branch. And then we will trigger an automatic build using the pull request. The intended audience for this lab are those candidates who are studying for AZ 400, and others may be DevOps engineers at the junior and senior levels. They may be DevOps architects. They may be Scrum Masters and the project managers. So the lab steps would be that we would automate the code integration with Azure Pipelines. We will initialize a local Git repository and push that to Azure repos and use the classic editor to define the build pipeline, run the pipeline manually, and then we will create a pull request trigger branch policy, and then using that we will trigger the automatic build using that pull request. So this is the environment which we will be getting before the lab steps start. And we can see that we have an organization. In that we have a project, and then we have some data at the repo inside that project. And post the lab completion, our environment would look like this. That in the same organization of the collection, we would have a project in which we have a repo, we have a continuous integration, build pipeline, and the output is in the form of built artifacts. So what continuous integration is? Continuous integration is built on two main pillars, the building code and the testing code. So if we talk about the build process, okay, so build pipelines connect to the code repository, perform a build to produce the artifacts, that is the build artifacts. These build artifacts are packaged and created from the build stage, as we can see from the image itself. Build artifacts are the packages created from the build stage ready to be consumed later in the DevOps processes or the pipelines. The build artifacts are consumed in the continuous delivery portion of the development lifecycle. Right now, we are talking only about the continuous integration, not the continuous deployment or the continuous delivery stages. And obviously, build pipelines are generic tools that can integrate with the Git repository or the Git-based repository and satisfy any build requirement. Now, talking about the next stage, we will have to first focus on what is tasks. So, build pipelines are made up of certain number of tasks. These tasks are various things that you will like to perform in the pipeline stages. For example, you may want to grab the source code, package it into an artifact, and ready for the release pipeline to consume. Okay, so going further, we will talk about the code quality and code testing. So the part of continuous integration is the continuous testing and checking the quality of the code. And code quality tools let you merge, clean the safe code into the repository so that you can be sure that your code won't break the application in the production stage. Applications like Sonar Cloud helps you detect bugs and vulnerabilities and give you feedback on your code to find and fix any issues related to your code. So you can install the Sonar Cloud extension, the Azure DevOps environment through the Visual Studio Marketplace as well. So going further, we would be starting our lab. Okay, and we already discussed what are the all the stage of the lab. So we will start with initializing a local Git repo and push that to the Azure repo. So let's do that. So friends, we have the lab setup. This is a simulation lab provided by a particular organization, and then we have the Azure portal, and we have logged in with the same ID which has been provided by this particular lab, and these credentials are valid only till the time this lab is valid. After that, we cannot use these credentials. So anyways, let's get started. So in this lab setup, we will go ahead and initialize the local repository in this ID and push these files to the repository in the Azure repos. So for that, we would have to start with the terminal. Let's click on new terminal, and we would have to set up some global configuration details for Git by entering certain commands. And let's do that. So let me minimize certain stuff that's not needed. Okay. So I will use the command that is git config. So for the name, we have to use the command git config, and it can be dash dash global user dot name, and my name we can put any name. So I would just hit enter. Okay, and then we would have to set up the global user email address as well. So I would put a dummy email address here, that is git-config global user.email and abc123@outlook.com. It does not matter, but in practical, in production situations, production environment, we have to make sure that we put the right information here. This information is connected to the changes you make to the code and will appear in the code history as well. And it helps you and others to identify what changes were made and by whom. Now let's go ahead and make some changes in the directory. So we would type here cd and then ca repo. Let's check what folders are available first, what directories are available. ls. So we can see ca repo and lost found. So lost found we don't need. So we would go ahead and use ca repo. Hit enter. And then we have to initialize the empty repository. So for that we would have to use git init. Enter. So we can see initialize git empty git repository in this particular directory. This git init does not automatically populate the files in the working directory as a part of the repo. You would have to add these files manually and yourself as well. So let's proceed ahead and try to stage all the files in the directory. So for that, we would have to use the command git add, and we can put the address means the number means the file. So for that, I would put a dot, which means that all files will be staged here. So hit enter. So every time whenever we make changes, we can type this command git status. So we hit enter and let's see what happens. We can see we are on the master branch. There are no commits yet, done yet. And we have some new files, that is source main parameter.json and then source virtual machine.biceps. Let's verify this. We have a project here, that is CA project. And if we go inside that, we would see that these files would be present. It may take a while, but let's ignore that for the moment. So now that we have successfully staged the new files and these are ready to be committed, although it says that no commits yet, but it is ready for to be committed. That is saving to the branch. So for that, we would use the command git commit. Let's do that. But not only the git commit, we would have to make sure we use the right parameters here. Dash a, dash m, m for message, a for committing all the stages. Okay, stage contents, I would say. So m we can put, let's say, a new remote repo. Hit enter. So we can see that master root commit, and this is the ID, new repo, a new remote repo, two file changed, 178 insertions. Okay, let's verify this. We can see here repo. Mm, commits. Okay, let's leave it for the moment and let's proceed further. And now we would have to put a command to create a connection to this remote origin in the Azure repos. That is why we're not able to see those information here. So we would have to use this link. Okay, that is get remote add origin, and this particular link we would have to put. So let's copy this and let's paste it here. Okay, so this is done. Get remote add origin, and this is the origin information. So this sets the pre-created Azure Repo CA project as your remote repository that you will push to. At this stage, you will need to check if the DevOps environment is ready or not before being able to push to a remote repository. For example, if the environment is not ready and if you start pushing, the environment may break. And also, let's say if you try to access this link, it would ask you for the credentials, which we can use it from here. That is the same DevOps URI link, and then the use means admin credentials are here. Okay. So what exactly we did that we initialized the empty Git repository. Okay, we added all the means stage information to this, and then we had committed the files, and then we have also set the remote repository as well. Okay, so now we would have to push the local branch to the Azure DevOps to initialize the remote origin branch. So for that, we will use this git push dash u origin dash dash all commands. So let's do that. It is asking for the username. So we would put the same username which we are using here. So it would be admin DevOps, enter. Now it would ask for the password. So we can copy the password from here. Okay, and just paste it here. Writing or pasting the password would not be visible. So we have to just hit enter, ensuring that we have the right credential enter. Okay, so we can see that the stages are completed. I mean to say that we have entered the password and the things are working fine. And what we exactly did that we have pushed the files and the push is complete, and we will be now able to see that a local CA repo git repository has been replicated remotely. Earlier we were not able to see anything here, so let's click here again repo, and then we can see that the source files, that is these files we saw earlier here, these are visible, that we have pushed the information to the remote repo. All right, so that's all in this step. What we did that we have successfully initialized a local code directory as a Git repo and then pushed it to the remote repository in the Azure repo. So our next step would be to use the classic editor to define a build process for the build pipeline. So there are multiple ways to create a build pipeline. In this stage, we will be using the classic editor. That is a more accessible method for creating the pipelines, especially for the beginners and those who are not familiar with writing pipelines as a code, for example, using YAML, etc. So let's proceed to the lab, and we have the Azure DevOps page here. Let's unpin it. Okay. And let's go back to our Azure DevOps environment. The first page, we would go to the CA project, and then we will have multiple options. We already seen the repo, that is remote repository, and then we have the pipelines. So here we will create a build pipeline with continuous integration using the classic editor. So let's click on the pipelines. We don't have any existing pipelines, so we will have to create our first pipeline here. Click on create pipeline. Okay, so we can see multiple options here. One is the where is the code first of all. So we have the code at Azure repos, and we have the GitHub Enterprise Server. These are the YAML based. We might have other Git based repositories subversions at a CVS or so we can also use the classic editor. So these are the we can say YAML based repositories. Okay, and this is a non-YAML based repository. So let us start with this. Use the classic editor. It may take a while to get loaded. Okay, so we are on this page where we have to select our repository to the non-YAML based repository. So we will choose the first one, that is the Azure Repos Git. We have the team project that is already the same name, that is CA project. The repository would also remain the same, CA project, and the default branch would be the master branch as we don't have any other branch for now. So we will click on continue. Now we have to check that we need to use a template or we need YAML based or some other options are also there. So let's click on empty job. Okay, so here we can see that the pipeline, some settings need attention. Obviously, we have the CA project CI, that's the name of this particular pipeline. We have the agent pool here. Okay, so we have to select this. So there are two options. DevOps pool does not have any agent, so we would have to choose the default one here. Okay, and then we would have to do some other changes here. So let's do that. Let's click on the plus sign here, and here we would have to type copy files. Click on add. It says that copy files from the source to the target using pattern matching file paths, not the folder paths. Click add. This is done. And now we have the copy files too. We need to make some changes here. As it says, some settings need attention. So the task version here remains the same, that is 2. Okay. The display name, we can put here whatever we want. This field will populate automatically based on what is filled in the source folder and target folder field. All right, so that is why. So let's configure the source folder. So for that, we would have to put a dollar symbol, put inside the bracket, build dot sources directory. So it is build dot sources directory. We have to make sure that the spelling is correct. If it is if has certain errors or a spelling mistake is there, so the pipeline would fail later. Contents, that is star star asterisk, and the target folder would also be the similar. We have to put here build dot artifacts singular staging directory. This is done. So what we did, task version is 2, display name, uh, since we discussed that it would populate from the source and target folder. So the display name would remain the same as the target folder name. And in the advanced section, we would have to move some means do some changes, that is clean target folder, so that the data which is present in the target folder that gets deleted, so that our new data comes inside that target folder. Delete all existing files in the target folder before copy. All right, so this is done. So we have to proceed further and do some other changes here. All right, so what exactly this source folder does? Source folder tells Azure Pipelines that is the location of the files that you want to copy from. And this is a predefined variable. That is why we have a dollar symbol here. And it states that the local path on the agent where the source files are downloaded. And the target is just where you want to copy the files to. All right, so again, let's proceed and click on the plus sign. And let's do some other changes here. We would have to write here publish build. Let's do that. Publish build. So we can see publish build artifacts. Publish build artifacts to Azure Pipelines or a Windows file share. In this lab, we will not use the Windows file share. We will use the artifacts to the Azure Pipelines only. Click on add. Again, we will click on this, select this, and do some changes here. The task version would be 1. The display name would be publish artifact drop, and then artifact name. That is again the drop. That is why it is populated here. And then we have publish to path to publish, that is build.artifact staging directory. Okay, so, and then we have the artifact publish location, that is Azure Pipelines. We have some other option as well, for example, a Windows file share, but we don't need that here in our own lab. Now we'll have to click on trigger here. Uh, we don't need to make any save any changes right now. We would have to select all the relevant stuff, and then only we have to make sure that we select the save and queue and then save it. So let's click on triggers. Let's wait for a moment. And here we have to make sure that enable continuous integration is selected. All right. And then we have some other options as well. So let's click on this other options. We have the build properties, build job. We have other options as well. But right now, our main focus are these 3 links. The image URL. Let's copy it to a particular uh, notepad. We have the image URL for a specific branch, and then markdown link. The most important would be the markdown link. We would see it later. Okay, so this is done. And now we have to finally save and click on save and queue and then click on save. The folder path will remain the same. We don't need to make any changes here. Click on save. Okay, so in this lab step, we have created the build pipeline using the classic editor in Azure DevOps. Our next step would be to run a manual build process. Let's go inside our lab. So let's go back to the home page and then go inside the CA project. We have the pipelines here. Okay. So in this lab, we will manually run the build pipeline against the master branch of the repo. And in the real organizations or in the production environment, it might be wise to first test your pipeline against a feature branch, not the master branch itself. So click on the pipeline. We already did that. And then click on that project, that is CA project CI. Let's say no runs yet. Click on run pipeline. So now we can see that we have the agent pool and the branch or the tag. So we have to make sure that the agent pool remains the same, that is default, and we only have a single branch, that is master branch right now, that is default one. Okay, and the variable, one variable defined. So you can see system debug is false. So we can put it as true as if we want the detailed debugging information. And then we have to enable the system diagnostics to get granular information about what changes were done. So this means that the pipeline will, or the build pipeline will run against the resources in the master branch of the repository. This one. So the files in the master branch or the master repo will be copied to the artifact staging directory and ready to be packaged, and then packed as the artifact and published to the or the Azure pipelines. And they are ready to be consumed by another task in the pipeline or another pipeline itself. It may be the case. So let's click on run. So let's see what is the result of this stage. It says that agent job 1, it is in queued status right now. It may take a while for us to see the status and the logs. So we can see that the status is now in running state and duration is 16, 17, 18. It is, let's say, increasing. Let's wait for a moment. So we can see that right now the agent job 1 has run successfully within 27 seconds. And so in this lab, we have tested a build pipeline against the master branch of the repository and checked the result of the run, that is success. So let's click here on the agent job 1 and we can see that there are various sub stages, that is initialize the job, check out the project, master, okay, and then copy the files, publish the artifact, post job checkout, and finalize the job, and then report build status. So we can see if we click here, we can see the stages here, and we can see other things as well. For example, system.debug is true and agent diagnostic is true. One artifact's produced. So if we click here, we would go to that artifact in the drop. So let's go back to our same page, that is the Azure DevOps. So in this lab step, we have tested a build pipeline against the master branch of the repository and checked the result on the run. That is, the run was successful. Now, our next step would be to create a pull request trigger branch policy. So, the obvious question is why we are going to do this. So, let's assume, or let's say that a continuous integration you can say, gives the developers the opportunity to focus on developing code, automating the building and testing of the code to make it easier and simpler to catch the bugs and problems early in the dev cycle. So as a part of CI process, you may want your new codes to build after merging to the main code base in the master branch from the feature branch, I would say. So in these cases, the pull request trigger branch policy might be the answer or the right option. So pull request trigger in continuous integration makes it easier for the developers to submit the code reviews for the code and automate the build once the pull request have been approved by the relevant authority or the approver. So to do so, we would have to set up a branch policy on the build pipeline. So right now we are on the Azure DevOps page, but let's go back to our lab or the terminal, and we will see the list of current local branches by using the git branch command. So let's do that. Git branch. So we can see that only the local master branch of the repo is present. That is also the current working branch that is denoted by the asterisk on, on master branch. So now we need to create a new branch, and for that we can use two methods. One is the direct way, that is get checkout. So let's do that. Get checkout dash B, and then we would name the secondary branch of the feature branch. So it is get checkout dash B feature branch. Let's put a dash before branch. Okay. So what exactly it is going to do? That is, it will create a new local branch, that is feature branch, and then it would also swap over to the new branch, that is switch to a new branch. Let's do that. Hit enter. So we can see that switch to a new branch. So let's check using ls. No, ls, not ls. Ls is not needed here. The other option was that we would have to let's use the git branch. Okay, git branch and then feature branch. If we use this command, it gives a fatal error, that is branch name already exists. But if this was not available, so it would create a branch in the same way. But it would, this grid branch would not change the branch from master to feature branch. For that, we would have to use again the git checkout feature branch option. So let's see the branch information using the get branch option in the command. So we can see that earlier it was the asterisk was master, meaning that it was the current directory at that time, current branch at that time. But right now the feature branch is a current branch. So let's see these CA repo. We can check it either from here because this simulation lab has provided the option. Otherwise, we could have checked it by here, ls minus or ls dash ltr. So we can see total 4, and then we have all this information available here. So we have this source folder. Okay, so we have to create a new file here under the CA repo. Let's minimize this. Let's create a new file. We will make the readme file, that is readme.md file, readme.md. Okay, either we can create it from here or we can create it from here as well using the touch command. If it is folder, we can use the mkdir command. Now we use the ls command, so we can see readme as well present now. And also we can see number one, that is it detects some changes and then it highlights it here. So let's go inside this readme.md file, and then we would have to use that markdown link. So earlier we copied this markdown link, so we will just copy this and just paste it here, the readme.md, and then click on save. Let's go to file and then save. This is done. Let's cat here. Since Linux is case sensitive, readme.md. So we can see here. Okay. So this is done, and it does not matter that if you make the changes first and then make the new branch and commit that to the branch. You are also allowed to make the branch first and then make the changes and then commit to the new branch. The order of operation here does not matter, provided the last thing you do after making a change and creating a branch is committing to the new branch, you can say. Now that we have made the changes, we would have to stage all the changes using the git add command. Let's do that. Git add dot means all. So it's done. Let's see the git status. So we can see on the branch, feature branch, new file, that is readme, and that is stage file. So we have successfully staged the new file and ready for committing to the remote branch. So for that we would use the git commit command now. Git commit dash a means all, dash m means we would have to put a message here, added. Let's put the exact case, readme.md file. Okay, this should be fine. Hit enter. Feature branch added readme.md file, and let's see again the git status on branch. That is feature branch and nothing to commit, working tree, clean. Whatever we had to commit, we have done it earlier only, so we don't need to make any changes right now. So now we would have to push the local branch to the Azure DevOps after the commit has been done. So for that, we would have to use the get push command. Get push origin, and origin would be feature branch. Enter. It is asking for the username. We would put the username from here, and then it would ask for the password. We would put the password from here. So we can see that after we have entered the credentials, the information will be pushed to the Azure DevOps. So let's go back to our Azure DevOps page and then CA project and then Azure repos. And now we can see here the sources. The last change was done 33 minutes ago, but the commit was done recently. You updated feature branch just now. Because we are in master branch, we are not able to see anything right now. So let's go back to the feature branch. So we can see here that we updated feature branch just now and readme.md was committed just now. Now in the repos, we have to click on branches. Okay. So we are on the branches page where we can see all the branches available. So let's click on the feature branch as we need to create a policy for that. Click on the three dots here and we will have to drag it down and we'll see the branch policies here. Okay, so here we would have to add a new policy by clicking the plus sign of the build validation option. So we can see build validation, click on the plus sign. We have the add build policy. We have to select the build pipeline here. Path filter is optional. Trigger, we can put it as automatic and policy requirement is required. And build expiration is after 12 hours if the branch feature branch has been updated. And display name would be PR trigger. PR trigger. Any name we can put, but right now we are just putting it here. And then we would save it. So in this lab step, we have created a new branch. That is the feature branch to submit a change to the repository and then created a pull request branch policy or the build policy on the build pipeline to trigger the pipeline build when a pull request is approved by the approver. Now we are going to trigger an automatic build using the pull request. So let's proceed further. So we are on the Azure DevOps portal and let's go to our project and then we will have to go to repos and then we have to click on pull request and then we will have to create a new pull request. So let's click on this new pull request. So here new pull request that is feature branch into master branch. Okay, and then the title we can put added readme file like this as we did earlier in the CLI. And then we have to complete this and make sure that we have certain reviewer. For example, it may be administrator in our case, administrators, that is built-in administrators, the system default administrators. So it is customary to have at least one or more than one external reviewer of the code when attempting to merge the changes to the feature from the feature branch to the master branch. And this prevents any unwanted or unresolved code into means to enter into the main code base that could potentially break something. So for that purpose, in this lab, we can use the administrator as the reviewer. We don't need to make any other change here. All right, so we will click on create. It may take a while. Let's close it. Let's checking for the merge conflicts if there might be any. Okay, it says that no merge conflicts and last check just now. In the real scenarios, you're not the one who should be approving your own pull request. In fact, there may be certain policies in place that would prevent that. Okay, so let's drag downward. We can see that admin DevOps created a pull request. So let's go ahead and complete the pull request using the complete option. Here we have the option to approve or reject or do some other changes with some suggestion or wait for the author like that. So click on complete. It says merge, no fast forward. There are some other options as well as squash, rebase, and these are all related to Git flows. All right. So we have to unselect this complete associated work item after merging, and we have to click on this complete merge. Again, queuing pull request to merge. We can see admin DevOps completed this pull request just now. Merge PR1 that is added readme.md file. Okay, so let's go back to the Azure pipelines page. Mm, Azure pipelines. So we can see here that the changes which we did here that is reflecting here as well. We can see that the build pipeline we have created ran after an approved pull request. Okay, and once it is approved, once it is completed, and it would go green. So that is what it happened. So let's go back to the repos. Azure repos. We're in feature branch. Let's go back to the master branch now. Master branch, that is the default one. So we can see here that readme.md file some 10 minutes back, there were some changes done. Okay. And if we see here feature branch, some 10 minutes ago, the things happened. It may take some time. And once that is done, so you will see here in the master branch that the changes was successfully merged and the status badge would be succeeded. So in this lab, we have created a build pipeline and triggered an automatic build against the master branch by approving a pull request to merge the changes from your feature branch. To do that, we have created a branch policy that accepts the pull request as a trigger for the build pipeline to run. So thank you so much. That's all for today's session for continuous integration. I hope this gives a clear understanding of how the continuous integration can streamline your development workflow and improve the collaboration across the teams. If you found this video helpful, don't forget to like, share, and subscribe for more cloud and DevOps insights. I'm Shams Raza, and I'm going forward to bring more practical knowledge from the world of Azure and cloud solutions. And possibly I would be bringing certain playlists for AWS and Google Cloud Platform as well. Until next time, keep learning, keep building, and keep innovating. Thank you so much.